Alrighty. Good morning, afternoon, evening, and good night to all of my wonderful students who are watching this broadcast, whether you're watching it live or you're watching it on the replay. So this is Mr. Lowry. Hi. If you haven't seen the office, this is what it looks like. What I'm doing right now is I want to go through a couple of the problems from the lesson 2.17 and 2.18 activities or lesson that were done in class. I'm not going to be on here too long. I don't want to make a too long of a video. However, I do want to kind of hit some of the highlights just to ensure that the major notes are addressed and that you have understanding of what was going to be a takeaway. So I believe my chat's open. We'll see if you're watching in real time. So we'll see. I don't know. I'm about to find out. But I am going to go ahead and kind of share my screen so that you're able to see part of the PowerPoint that is there now. For those who I have on a different day, don't you cheat now, because I haven't had your class. You haven't had your class yet, so you don't quite know what we're going to be talking about, and that is a-okay. By the way, if you hear a kid screaming in the background, that is one of my children whom I love. So this is kind of just an opening screen from the PowerPoint. I want to get to one of the major slides that we talked about, and that would be this one right here. So a couple of your classes I got to, and the other classes I did not. So I want to use this to highlight some of the major elements that are here. And hopefully my pen will work. I think it will. Okay, so it is working. Good. All right, so that's fine. So these two graphs, they're related to the rational function that we have. So as I've kind of mentioned in class, and I'll say it again here, the graph for 6 over x is the graph that is above. I was hoping it did not do that, but that is okay. Let me see if I can get back to the screen. Okay, let's get the pen and boom. So like I said, f of x equals 6x is that graph above that. And then 6 over x minus 1 is a graph right there. Now, one of the major things from class was talking about asymptotes. And what we talked about in class, we talked about how asymptotes are those boundaries or those items where situations cannot happen. And the connection that I was hoping to make in class is that with our asymptotes, there are two particular asymptotes that we can use or we talked about. One is called vertical, and the other one is called the horizontal. So vertical asymptote has a lot to do with our denominators. So the x and the x minus 1. And the point I wanted to leave you with is that when you look for your vertical asymptote from the equation, what you're looking for is the exact value that will cause your denominator to equal 0. Now, the reason why you want to find that particular item is because we talked about how we are not able to divide a fraction by 0. We do it on our calculators, we get error, domain mismatch, all these things that basically says you're not going to get an answer. So how that shows up in our graph or the function is there's an asymptote. There's a line that the graph will not provide an answer for. So with that being the case, like I said, if this was 0, we would have 6 over 0, and it did it again. That's okay. Let's go back. So this would be 6 over 0. Nope, did it again. Let's go back over here. All right. So this would be 6 over 0, and our calculators say undefined. So that's why when we look on the graph, you will notice here that it does not cross that line. Now, when we look at g of x, you have this x minus 1. So putting 0 in for that x doesn't change anything. We end up with having negative 6. So that's why at 0, or when you put in 0 for x, we get negative 6 as an answer. For this one, you have to find what would make it equal 0. And that would be if x was a 1. because then we would get 6 over 0. We get our, it doesn't fit. And then that's where we look at the graph and see it doesn't cross. Now, if we look at the full graph that is here, what we notice now, once again, 6 over x is the graph that's below it. And then 6 over x minus 1 is a graph that's above. So if we look at those graphs, which is a full graph, we recognize that, oh, now with 6 divided by x minus 1, it's not trying to touch this line here. So that's our asymptote, and that's at x equals 1. Likewise, with f of x, we notice it's getting close to this y-axis, which is also known as the equation x equals 0. So that's the connection with the vertical asymptote. Now, when it comes to the horizontal, we haven't fully manifest or fully explained that one quite yet. But on a conceptual level, what we've talked about is how when we look at our particular graphs, we talked about how, not that, clear that and go back to the pen. We talked about how when we talk about horizontal, we're talking from left to right. So we have to look horizontally, and what we see on this 6 over x is that it's not trying to touch 0. Likewise, on the 6 over x minus 1, it's also not trying to touch 0. So that would be our horizontal. So the horizontal asymptote for both of these would be y equals 0. Now, the reason why it's y is because we're talking about what line would cross the y-axis. So that is why it is the y equals 0. Now, the example we did in class, or another example we did in class, and then I'll go ahead and wrap up this video for us, is we talked about how if we ran across or ran into having a equation like g of x being equal to 12 plus 4x over x. And it's one of those problems where we talk about how else could you rewrite this? One way you can do it is that since this is a combined fraction, give each items in the numerator their own denominator of x, because that's how you combine like terms anyway. Now, with that being the case, what we can also do is now we can do some reducing. Now, 12 over x is just going to be 12 over x. There's no ifs, ands, or buts about that. That's just 12 over x. But for 4x over x, we can divide off the x, and we're just left with a 4. Now, if we were to actually graph this, what we found is that this number represents a horizontal asymptote for this equation. So another example of that would be h of x is equal to 17 minus 36x over x. We can rewrite that as 17 over x minus 36x over x, giving each of these fractions or each of these numerators their own denominator. Now, 17 over x, it's just 17 over x. There's no reducing that. However, with 36x over x, we can take away our x from both of these. So we get minus 36, and we recognize that negative 36 is our horizontal asymptote. Now, the revelation that we got to, and this will expound more on Friday or next class when we are fully together, is if I'm reducing the x here, that is the same as me going back and talking about using division from topic number 2, whether it's LPD or whether it's the box. So we're going to pick up there in class on Friday. And so this is a revelation we have, because it's not going to be just these, what we consider basic equation that easily jump into getting our horizontal asymptote. There's actually a couple other scenarios we have to be able to handle. But the good thing about it, or the potential, is we've already prepared ourselves for it. So hopefully it will land pretty safely for us. So with all that being considered, I just wanted to kind of give you a touch of video of what we talked about in class. Hopefully this kind of gives you another round of hearing what we talked about. and hopefully it gives some clarity or just some landing spots to go. So with that, I'm gonna go ahead and end tonight's video. Hopefully, if there's any questions, you definitely feel free to reach out to me at the different methods that we have. Always know you can always reach out, email, Teams chat, or what have you. And yeah, until I see you in class, have a wonderful, great day. Bye now.